Good evening. Welcome all. On the behalf of StudyIQ IAS English, my name is Pritesh Maturkar. I extend my warmest regards to everyone, those who are watching me live and those who will be watching these sessions in a stipulated time period. So, we have started this journey, an incredible journey rather I would say, that is entitled Geography Through Maps, wherein I'm your tour guide and I'm taking you all to a world tour wherein we will understand the intricacies of a discipline called as geography through maps, because geography has got a very wide content, it has got a very wide scope, so we require some tools to understand this discipline. It's just like this, guys, that if you need to cook something, you require some proper tools so that you get a very hot tasty meal. Similarly, if you want to master the discipline called as geography, and mind you, civil service examination does require some level of mastery, not a very high level of mastery but some level of mastery. So we'll be using the tools of mapping, we'll be using the tool called as atlas for mastering some of the basic tidbits of this discipline. So before I move ahead, I will just point out few things which I point out in the beginning of every lecture. The first thing being that this is a continuation based series, means this is our 7th lecture that we are going into foray with, and the previous lectures I have been building upon some of the basic concepts. So every lecture will introduce some new concepts, every lecture will introduce some new topics, and we will also use detailed maps in every lecture, and the specificity and the intricacy will increase in every lecture. So those of you who are watching me for the first time, please make sure that you also go to the previous lectures and you just quickly revise whatever I have taught. You can speed up the things. You have now got good computers, good mobile phones, so you can have 1.25 1.5x speed so that you can just zoom past and understand the concepts. So in every lecture I first start with the discussion of the previous lecture, so 5 to 10 minutes are given towards revision. Then in every lecture I tend to introduce you to new concepts, and then we apply those concepts on the atlas. So this is the typical flow of lectures that we have in this series, and through this series I intend to cover at least 60 to 50% of your geography GS curriculum. So my coverage primarily will be the 11th NCERTs, both of the NCERTs, and a book called as Certificate Physical and Human Geography by Goncheng Leon. So this will be my primary syllabus coverage, but I will also introduce you to some of the higher level concepts as and when required, because these concepts are vital for understanding the present day geographical circumstances. You all know that we are all living in the era of global warming induced climate change. So for you to understand this, we do require some advanced concepts. So I will be also pouring into that, but gradually, not at one go. Okay, remember guys, civil services preparation is a marathon, it's not a sprint race. You have to be consistent in this preparation. Okay, so in these lectures, this is our typical outlay in each day, and tomorrow's lecture will be continuing of this lecture. Okay, so before starting today's lecture, I will just quickly introduce myself. My name is Pritesh Maturkar. I will be your primarily faculty for handling the GS part of geography. So treat this curriculum as the basics of that. Treat this curriculum as a preparatory course for the GS batch. If you do this series properly, your GS, we can take it at a zooming speed. Okay, there is a famous word called as blitzkrieg. Okay, it was the German mode of attack during World War II. Okay, so you launch the offensive in one go and you obliterate the entire enemy in a very short period of time. So if you do this curriculum properly, we can have a blitzkrieg in the main GS part. Okay, you can reach out to me on a Telegram channel called as Geography by Pritesh Maturkar. This channel is free of cost, of course, and in this channel I daily keep on posting the relevant materials, the relevant PDFs which I feel are important, and whatever is happening in this discipline and whatever is happening on the earth per se from the geographical perspective. So please do join the channel called as Geography by Pritesh Maturkar. The joining link is this, Geography by Pritesh. So you can just search @ Geography by Pritesh on Telegram and you are free to join this channel. Okay. In this channel you will find article links, in this channel you will find infographics, and in this channel you will also find PDFs. So please keep those PDFs in your file folders so that you can directly translate those PDFs into your mains answers. And guys, please remember this, okay? Those who are watching me and those who will watch me in further, please don't watch this content only from a enjoyment perspective, only from a kind of analyzing perspective. Let's see what each faculty is teaching, what who is teaching, and crisscross comparing between different faculties, different kinds of institutions. Why? Because number one, you have limited time frame, and number two, you need to see the content from utilitarian perspective. Okay, so unless and until you work upon the content on which I'm going today, it's of no use, guys. And that is my number one premise with you. Whatever I'll be teaching you, my ultimate aim with all of you is that this needs to be translated as marks in the mains. You need to be extremely hungry for marks in civil services examination. Okay, one thing should keep on ringing your brain: whatever we are doing, will it translate into marks? That's it. Any content you see, any content you consume, any content you write, please see to it that that content has utilitarian value in terms of marks per se. Okay, so you are free to join this foray on Telegram, and I'm giving my guarantee that you will have at least 50 to 100 marks in mains from this channel and at least 10 to 15 marks in prelims. That will be the gravity of the information which I will share with you on this channel. Okay, so let's start today's lecture. So first of all, I will be quickly revising whatever we did yesterday. So I'm utilizing again the Earth's atlas for you all. Okay, so in yesterday's lecture, I introduced you all to the tropical areas. Okay, tropical areas do have high pressure conditions. Tropical areas do have inhibited cloud formation. So because of this, the tropical areas receive direct insolation of the sun. This is not what equatorial regions have. Equatorial regions, because of intense vertical convection, you will have heavy downpour due to cumulonimbus cloud formation, whereas on the tropical areas, because of local high pressure conditions, cloud formation will be inhibited. So number one, tropical areas will now become the world's hottest areas. So anywhere you go on the tropical areas, you will find tropical and subtropical hot deserts. So this is the first point. Number two, you will find what kind of vegetation on the tropical areas? You will find xerophytic vegetation. Okay, that kind of vegetation which is highly adapted, which is highly accustomed to surviving in extreme conditions. Mind you, the climate on the equator was warm, it was wet, it was humid. Okay, whereas the climate on the tropical areas, it will be hot, dry, arid slash semi-arid. Okay, hot, why? Sun is shining directly. Dry means whatever water comes, it evaporates. You either have evaporative losses or transpirative losses. And number three, because of such evapotranspirative losses, the place will have wattage scarcity. Hence, the place will become arid to semi-arid. So please remember this difference between the tropical areas and the equatorial areas. So I'm quickly jotting down the tropical areas for you all. So in Mexico, we did discuss the Great Mexican Plateau. It is called as the Mexican Altiplano. It is situated between two ranges called as Western Sierra Madre and Eastern Sierra Madre. So this light yellowish color that you see, okay, it's again a kind of desert topography. Mind you guys, I'm just using this atlas for reference. In details use of atlas, country by country wise, region by region wise, I will open up those maps too. Right now we just have to develop our content, so I'm utilizing this atlas. Okay, so this is the Mexican Altiplano, the plateau between the two mountain ranges of Eastern Sierra Madre and Western Sierra Madre. So in between that, you have a dry xerophytic region called as the Mexican Plateau or the Mexican Altiplano. Okay, if we move ahead with respect to Africa, so if I take the same map on Africa, you will see the light yellowish color or the light brownish color on a very large scale. So this is our Africa, and this is where you see this color. So this is where the Tropic of Cancer will pass through Africa. So this great region, this is called as Sahara or Sahel belt. Sahara or Sahel belt. Okay, and mind you guys, Sahara desert is not the world's biggest sandy desert. Okay, as I told you yesterday, Sahara will exist as pockets. So we'll have small pockets of Sahara. Some of the pockets I introduced you to yesterday. So in Algeria, you will have Fezzan. In Libya, you will have Libyan desert. In Egypt, you will have Western desert, Eastern desert, and in the south, you will have Nubian desert. Okay, and I gave you a very interesting tidbit with regards to the Nubian desert. I told you that the world's oldest pyramids and the world's greatest pyramids are not in Egypt. Okay, the world's greatest pyramids are there in Mexico, the Altiplano region. Those pyramids are called as the pyramids of Cholula. And the world's oldest pyramids, they also come from the Nubian part of from the Africa, the border of Sudan and Egypt. You had the great Nubian civilization, and those pyramids date back to around 4000 BC. So roughly 1000 years older than the Egyptian civilization. Okay. Next, if you move to Arabian Peninsula, the entire Arabian Peninsula is again light yellowish, indicating that it is a big desert. Okay, and this is where you have the world's biggest sandy desert expanse. This is where you have the world's biggest sandy desert. It is called as Rub al Khali. It is called as Rub al Khali, the land of the great empty. Rub, land of al Khali, empty. So if you go to Arabian Peninsula, Rub al Khali will be there in Saudi Arabia. It will extend in Oman. It will also have some foray into UAE. So this is where you have the world's single largest sandy expanse of the world. If you come to India, this light yellowish color, you have the Indian desert of Thar. But mind you guys, I told you that Thar has nothing got to do with Arabian desert, with Saharan desert. All the soils that we have in India, they come from this part. They come from the deserts of China and the desert of Mongolia. So here you have the Mongolian desert called as Gobi desert. Okay, but the Gobi desert is not a tropical desert. Okay, it is a mid-latitudinal desert. We will discuss it in some time ahead. What do you mean by mid-latitudinal deserts or the Central Asian deserts? But the soils that you have in Thar, they primarily come from Gobi. Okay, so these are some of the deserts on the Tropic of Cancer. So everywhere you go on the tropical areas, you will predominantly find deserts. You will predominantly find xerophytic vegetation. Someone is asking, is it for 2023 aspirant? Yes. Of course it is for you, because you will have just revisions. So you can just treat this as a revision lecture for your map entries too. Okay, so let's move ahead. Let's zone our thing to Tropic of Capricorn now. Okay, so on Tropic of Capricorn, if I'm discussing the first region, so on Tropic of Capricorn, you have in South America, you have the world's driest place. So if I'm zooming in over here, so this is where you have the world's driest place in South America. This place, it is called as Atacama. Okay, Atacama. Atacama is the world's driest desert. Okay, Atacama has not received rainfall for more than 30-40 years, the record being 55 years per se. Why it is world's driest desert? For that we need to understand its local topography. That we will do when we'll discuss South America in detail per se. But for now, just remember Atacama is the world's driest desert, and you have two cities over here called as Arica and Iquique. If I'm mentioning the cities over here, you have a city called as Arica and you have a city called as Iquique. Okay, I-Q-U-I-Q-U-E, Iquique. So these two cities are the world's driest cities, and both of them are situated in the Atacaman Desert region of South America. Now, if I move ahead to discussion of the deserts of South Africa, deserts of the African region, to the south of Tropic of Cancer, to the south of Equator, on the Tropic of Capricorn region. So again, this light yellowish color that you see. So here you have three very important deserts. You have the Namib Desert. You have the Namib Desert. Okay, here you have the Kalahari Desert. I told you Kalahari is famous for Okavango swamps. Okay, you have river Okavango. It is a marshy land, okay, and very peculiar marshy land of the world. And here you have a desert called as Great Karoo. Okay, Great Karoo. Karoo is basically the extensions of Kalahari into South Africa. So these three deserts, they dominate the Tropic of Capricorn region of Africa per se. Okay, and if I move ahead, if I come to Australia. Okay, so this is Australia for you all. Okay, and I told you yesterday that Australia is the best representation of desert topography. It is the best representation of xerophytic vegetation. Why? Because two-thirds of Australia is a hot desert. It is called as the Australian. It is called as the Australian outback. It is called as the Australian outback. Okay, why is why you have two-thirds of Australia's desert? Today those answers will be given to you in the form of conceptual understanding. Okay, so two-thirds of Australia being a desert, majority of its population resides in the southeastern part of Australia. So Australia is basically a great game country where hunting is a big passion, and Australian government actually pays you to kill rabbits, okay, because rabbits are a grave threat to the local ecology over there. So Australian government is one of the governments in the world which will actually pay you for killing animals. So if you do rabbit hunting, government actually pays you in Australia. Okay, so leave that aside. So the premise being that anywhere you go in the world on the tropical areas, predominantly you will having the subtropical and the tropical hot deserts. So this is what we did yesterday. So now we will start our today's session by understanding some of the aspects with regards to the tropical areas, and we'll move on our coverage to the covering of the temperate areas and the taiga and the tundra areas. So today's lecture becomes very important, as I told you yesterday, because in today's lecture we will be dealing with the cells on earth, the atmospheric cells on earth, and the pressure belts on earth. So today's lecture being slightly more technical, I want your attention very much on the board, because once you understand the pressure belts on earth, once you understand the wind patterns on earth, it becomes very easy for our coverage of the atlas and our analysis of the local topography over there. Mind you guys, UPSC in present day times is focusing on these aspects. If you pick up the previous year's papers, so one very interesting question came: how do the local mountain orientations affect the local climate of a place? A very interesting question. So in that question, basically what you needed to paint is that how do the mountains in a particular region affect the local climate, and basically it is the interconnection of the rainfall with regards to orography. So orographic rainfall, how it varies throughout the world. So that was the question of that year, just last year's question. So such kind of questions now UPSC is asking you in the mains. So you need to be extremely careful while doing the atlas. You need to be extremely careful while analyzing the atlas. Okay, and this is the primary goal with you all of me, that I need to make you comfortable with such kind of questions. Remember guys, you need to be comfortable with the content. You shouldn't get afraid of the content. Okay, never fear the content. Try to like the content, and eventually you will fall in love with the content too. Okay, but don't fall in love with geography, otherwise you will end up teaching geography like me. Okay, so let's start our today's discussion with the understanding of the other pressure cells on earth. Okay, so for this I will be relying heavily on diagrams. So this being a digital board, so I will be using the exact geometrical shapes that we have. So as you all know, the shape of the earth is spherical and it is basically geoidal. Earth is bulging in the center and it is flattening at the poles. So if I am telling you, so this is how earth is, it is flattening at the poles. So these are our poles and it is bulging in the center. So this is the shape of earth per se. Okay, so let's now understand some further intricacies of the earth's atmosphere per se, how you have variations in the pressure and how you have variations in the different pressure belts. We will now move towards the discussion of it. Okay, so let me first draw the axis of earth for you all. So for now, for our understanding, I'm drawing the Earth's axis straight, but you all know that the Earth's axis is tilted. This is for our sake of understanding. I'm making the Earth directly straight so that you get the concepts very properly. Okay, so this is the Earth's axis. Now I'm drawing the Earth's equator for you all. So this is 0° equator. Okay, so as you all know, on the equator, the sun's rays will fall perpendicularly, and as we move away from the equator, the angle of sun's rays will start becoming more slant. So if I'm considering the equatorial areas for you all, so this is our equator. So if I'm now showcasing the variation of sun's rays with regards to equator, so this is the perpendicular orientation of sun's rays on equator. As we move away from the equator, the angle of rays, it starts becoming slant. Okay. So consider these as the polar regions. Okay. So if I'm considering the angle for you all, so this angle, this angle, this angle, this angle is slightly becoming slant, slant, slant. So as you move towards the poles from the equator, the angle of sun's rays, it becomes more and more slant. Because of this, now what happens on equator, you have intense vertical convection. You have intense vertical convection on the equator, and because of this, on the equator, the air is always pushed upwards. The air is always pushed upwards. And as the air is pushed upwards, it will start deflecting towards the poles. It is always pushed upwards, and as it starts deflecting towards the poles, as soon as you have a kind of horizontal motion in the Earth's atmosphere, which force will come into play? The force that will come into play is the Coriolis force. Okay, Coriolis force is what kind of force? Coriolis force is an apparent force which acts on the moving bodies on Earth, and this force comes in play because of what? Because of the Earth's rotation on its axis from west to east, and as the Earth rotates, so the bodies start deflecting on the Earth. The deflection is towards the right in the northern hemisphere and towards the left in the southern hemisphere. So as soon as air translates upwards and as soon as it moves towards the poles like this, what will happen? The air, instead of sinking at the polar latitudes, it starts to sink at around 30 to 40 degree latitudes north and south, 30 to 35 degrees latitudes north and south. Why this so? Because as soon as the air starts to move, it starts to deflect, and as soon as it deflects, it cools down and it sinks. So what is happening actually at the upper reaches of atmosphere? Instead of the air sinking at the poles, it is sinking at around 30 to 35 degrees north and south. So the equatorial regions will have what? The equatorial regions will have the low pressure conditions, whereas as you move towards the tropical areas, you will have what kind of conditions? You will have high pressure conditions. So if I'm highlighting you this with regards to the Earth again, so this is our Earth like this. So this is our Earth. On equator, you will have what? You will have a low pressure belt. It will be called as what? It will be called as the equatorial low pressure belt. Why? Because on equator you will have intense vertical convection which will push the air forward, and this air will now move towards the poles, and as soon as it starts moving to the poles, it will sink across the subtropical or the horse latitudes called as the 30 to 35 degrees both north and south. So on 30 to 35 degrees north and south, you will have what? You will have high pressure conditions. So if you go to around 30 to 35 degrees north and south, you will have what? You will have high pressure condition, and it is called as subtropical high pressure belt. It is called as what? It is called as subtropical high pressure belt. Okay, so as we move towards subtropical high pressure belt at around 30 to 35 degrees north, you will have high pressure conditions, and on equator 0 degree you will have low pressure. So now guys, this is happening because of what? This is happening because of Coriolis force deflection. Okay, mind you, the air which is rising from the equator, the air rising from the equator is having a direct thermal association. It is because of the continuous bombardment of the sun. Okay, the sun is shining perpendicular on the equator, hence the air is afflicting from the equator, and the air sinking at subtropical high pressure belt, it is not because of sun, it is because of what? It is because of earth's rotation on its axis. Okay, so mind you, this subtropical high pressure, this is not thermally induced. Okay, this is not thermally induced. Okay, this is not thermally induced. I'm again reiterating, this is not thermally induced. This is induced how? This is induced dynamically. This is induced dynamically. And why this is induced? Because of Earth's rotation. It is induced because of what? It is induced because of Earth's rotation. Okay. So the formation of high pressure belt on the tropical areas is because of Earth's rotation. It is not because of the sun's bombardment. Now, if we move ahead above this, what will happen now? As this being a high pressure condition, the air will move out of this. Why? Because high pressure is a divergence zone. If you are increasing pressure in any area, the air will try to diverge from that area. And if you are having a low pressure area, air will try to converge in the area. So high pressure zone, it's basically an area of divergence, whereas low pressure zone is an area of convergence. So if I'm explaining you these two spheres of Earth now, okay, the wind movement between the equatorial low pressure belt and the subtropical high pressure belt. So the movement is somewhat like this. Now understand this very, very carefully. I'm drawing the half hemisphere for you all now. So let's just assume that this is our half equatorial, half plane of Earth. Okay, we are zooming on it. Okay, this is our equatorial low pressure belt. Okay, and over here you are having the subtropical high pressure belt. Okay, the air is rising from the equator. Okay, it is moving towards the polar regions, but instead of sinking at the polar regions, the air is sinking at the subtropical high pressure belt. Now what will happen? As this is a high pressure belt, the air will diverge from the high pressure belt towards the low pressure belt. So on the surface you will have what? The air will try to come towards the equatorial low pressure belt like this. So this is how the air will come from the high pressure belt towards the low pressure belt. And if I'm showcasing you on the surface like this, on the Earth's periphery, so the air movement will be like this. So you have one cell over here. What is happening in this cell? The air is rising from the equator, it is diverging towards the poles, it is sinking towards the subtropical high pressure belt, and it is coming back towards the equator. So this one cell, or the primary cell of the Earth's atmospheric circulation, this is called as Hadley's cell. This is called as Hadley's cell. Mind you, the name Hadley's cell. Okay, you have questions being asked from this part of geography curriculum. Okay, so please understand this too. Okay, so you have this particular pressure cell called as Hadley's cell, and why this cell is forming? Because the air is rising from the equator, it is diverging towards the poles, and instead of sinking at the polar latitudes, it is sinking at the subtropical high pressure belt around 30 to 35 degrees north and south both, and the air is coming towards the equator. So this first cell of atmospheric circulation, this is called as Hadley's cell. So now this is how the air should actually come from the high pressure belt towards the low pressure belt. But as I told you, which force will come into play if you are having horizontal movement on the earth's surface? Coriolis force. So just assume that this hand is coming towards you on the earth's surface, but will this hand now come straight? Imagine this is the my body is the subtropical high pressure belt and you all are the equatorial low pressure belt. My hand is now slowly coming towards you, but will my hand come straight? No, my hand will not come straight. It will start deflecting, and where it will start deflecting? Towards its right. So for me, this is my right, for you this is your right. Okay, so from my end the air will start deflecting like this. So between the subtropical high pressure belt and the equatorial low pressure belt, the air will rather come from northeast and it will go towards southwest, and this is called as the northeast trade winds, and in the southern hemisphere you call them as southeast trade winds or the trades. Okay, so let's draw those winds for you now. Okay, very interesting application of the dynamism of Earth's rotation. So I'm again drawing a very big earth so that you get this concept very fluidly. So this is our equatorial low pressure belt. Okay, and okay, let us draw one hemisphere only so that you get even a bigger perspective. Okay, so I'm drawing a very big earth. Okay, let it get to the entire screen per se. Okay. Okay, so very big earth I'm drawing for you all, and I'm considering only the 1/2 hemisphere. Okay, let us assume this to be the equatorial low pressure belt. Okay, so this is our equatorial low pressure belt. This is our equatorial low pressure belt, and let us now draw the subtropical high pressure belt. The subtropical high pressure belt is at around 30 to 35 degrees north and south both. So this is our 30 to 35 degrees north and south subtropical high pressure belt. Okay, this is our subtropical high pressure belt. This is our subtropical high pressure belt, and this is 0-degree equator. This is 30 to 35 degrees south. This is 30 to 35 degrees north. Okay, so ideally the wind should come in a straight direction. Okay, ideally the wind should come like this. So this should be the direction of the wind ideally. Okay, but will the wind come in this direction? Okay, ideally the wind should come like this. Okay, from subtropical high pressure belt to equatorial low pressure belt. Ideally the wind should come like this. Okay, from subtropical high pressure belt to the equatorial low pressure belt. But will the wind come like this? No, the wind will now start deflecting towards its right in the northern hemisphere and towards its left in the southern hemisphere. Okay, again I will be giving a very interesting application to you all every morning whenever you will brush your teeth. So please see the direction in which the water swirls in the basin. If the water swirls in the right direction, you are in the northern hemisphere, and if the water is swirling in the left direction and then it is going in the sink, it will be in the southern hemisphere. Okay, so this is the actual direction. Sorry, this is the direction in which the wind is supposed to come, but now the wind will come in a direction with regards to the Coriolis force orientation. So in the northern hemisphere, the wind will actually come like this. The wind will actually come like this. The wind will actually come like this. Whereas in the southern hemisphere, the wind will deflect towards its left like this. The wind will deflect towards its left like this. the wind will deflect towards its left like this. Okay, so this and this, these are now called as northeast trades, northeast trades and southeast trades, northeast trades and southeast trades. Guys, I'm slowly moving on to making you understand why do we have deserts on the western side only, why don't we have deserts on the eastern side of the continent. So this is very pivotal in understanding this. Okay, so between the tropics and between the equator, how are the winds flowing on the surface? The winds are flowing from northeast towards southwest. And in the southern hemisphere, how are the winds flowing? The winds are moving from southeast direction towards northwest direction. These are our northeast and the southeast trades. Now let us try to paint the same picture on the world atlas. Okay, so now let us open up the world atlas. So let me just quickly draw the tropical regions for you all. Okay, so imagine this is our subtropical high pressure belt like this. Okay, this and this is our subtropical high pressure belt. This is STHP. Okay, this is again STHP. Okay, and this is our equatorial low pressure belt. This is our equatorial low pressure belt. Okay, so if we are discussing with regards to the movement of winds between the subtropical high pressure belt and the equatorial low pressure belt in the northern hemisphere, the winds will come like this. This is the direction of the directions of the trade winds. So the trade winds will come like this. If we are considering the southern hemisphere, the trade winds will move like this. The trade winds will move like this. Okay, so this is the direction of the trade winds. So now guys, please understand this logic very carefully. Okay, we have discussed the deserts of the world. Sahara is to the western side, Mexican desert is to the western side. I have not yet discussed the deserts of the USA with you. Okay, but you must have heard a name called as Las Vegas, the gambling capital of the world per se. So once you qualify, you have to take me over there. Okay, I have not yet discussed this with you guys, but those of you who will qualify after watching these lectures, please take me to Hawaii. That is my dream destination, and I'm saying this on the record that if any one of you qualifies after watching my lectures, I will take you to a personal tour of Turkey and Egypt on my expense, any two of you. Okay? And this I will keep on repeating in subsequent lectures. Some of you might get motivated, qualify, get a good all India rank, and take me to Turkey. Okay? So that's my dream destination per se. Okay. So now let's move ahead to the discussions of that. Okay. So what you see over here is that the deserts are all on the west. Why so? Why the deserts are on the west? Because if you see Africa, so the north winds will bring rain where the northeast trade winds will bring rain on the eastern coast. Whereas if you move to the southern latitude, the southeast trade winds will bring rains over where to the eastern shores. Similar thing will Hello. Hello. Yeah, sorry for the interruption, guys. There was some delay with regards to the audio mixing. Extremely sorry for the delay. So I'm again reiterating back. So what you have the discussion with regards to, let's come back. So the trade winds are basically onshore on the east coast and they're basically offshore on the west coast. Okay. Apologies for the soundtrack delay. This being a digital medium, so we need to face such consequences. Of gross apologies from my end. So, what do you mean by this? That they are onshore on the east coast and they are offshore on the west coast? So, this means that you will have more rainfall on the east coast, and as you move away from the east coast towards the west, the rainfall will decrease. I'm again reiterating, guys. As you move from east coast towards the west, the rainfall will start decreasing, and hence this is the first reason that why you have tropical deserts on the western side of the continents. As you move from east towards the west, the rainfall decreases. Hence what you see over here as the light yellowish color, this part of the world, this part of the world, this part of the world. Okay, if I'm clearing this for you all. Okay, so this part of the world, this part of the world, this part, this part, this part, and this part. All of this is on the western shores. All of this is on the western shores of tropical lands. Why this is? Because number first reason, the trade winds are onshore on the east coast, whereas as you move towards the west, the trade winds they become offshore. Hence, the rainfall in general will decrease from east towards the west. So this is the general pattern trend which you find globally, and hence majority of the deserts are located on the west coast. So this is with regards to the trade winds. Now let us move ahead with the journey of our discussion of the pressure belts. So yesterday I introduced you to deserts. Today I gave you the primary reason for the location of deserts on the western side. Okay, the other two reasons they are linked to oceanography. So we will introduce these concepts in a later time period. The first reason being with regards to oceanography that on the western side of the deserts you have cold currents per se and you have ocean water upwelling. But don't get confused now, don't get frightened. Okay, please don't be afraid of the content. I am there to help you. Okay, so on the west side you do have some very prominent cold ocean currents. So cold ocean currents, they will do what? They will reduce the temperature, they will decrease the evaporation, and hence you will have no rainfall on the western shores of the desert. So that is the second reason. But for that, we need to understand the oceanic gyres. We will do that in a little bit time period. Okay. So now let us move ahead with the discussions of the pressure belts of the earth per se. So I guess everybody is now clear with regards to this arrangement between the subtropical high pressure belt and the equatorial low pressure belt. Now let us move ahead to the discussions of pressure belts above. Okay. So now let's move between the discussions of 30-degree south, 30-degree north, and 60-degree north and 60-degree south per se. Okay. So now if I'm considering the pressure belts between 30-degree north and 60-degree north, so this is our subtropical high pressure belt. Okay. This is our equatorial low pressure belt. Okay. So on the equator, the air is rising, it is diverging towards the poles, it is sinking at the subtropical latitude, it is coming back towards the equator. So this completes our first cell, that is called as Hadley's cell. That is called as Hadley's cell. Okay. Now, as you move away from the tropical areas towards the polar and the subpolar areas, the conditions are somewhat different. Okay. Now, as we have already studied that the equatorial regions are warmer and the polar regions are naturally colder. Why? Because of the axial tilt of Earth, the sun's rays are not able to strike with full intensity on the polar regions. Why? Because they have to travel through a greater amount of atmosphere and hence they start to desiccate, their intensity decreases. Okay, they become more slant, their intensity will decrease. So the energy received on equator is not the same as it is received on the poles. So poles in general are colder as compared to the equator, and this is called as the latitudinal zoning of temperature. As we move from equator towards the poles, the temperatures will fall. So, but naturally, if we are considering the North Pole, 90-degree north, this is going to be predominantly cold. Okay. So, what you have from 90-degree to 60-degree, what is happening over here? If I'm considering the latitude called as 60 to 65 degrees north. So what is happening basically in this latitude? Okay, what is happening basically in this latitude? You have one wind which is coming from the subtropical high pressure belt. Okay, and mind you, this wind is somewhat warmer. You have cold winds which are coming from the poles, and these winds are colder. So, what is happening basically at 60 to 65-degree north? Two winds are converging. One wind is coming from the, so if I'm showing you with the reference of my hands per se, okay. So, one wind is coming from the subtropical high pressure belt, the high pressure being the zone of divergence. Another wind is coming from the polar regions. Okay, this wind being the wind which is cold, which is coming from the poles, and poles are going to be predominantly colder. So these two winds are meeting, and across 60 degrees, what is happening? These two winds are forced to rise up. Guys, this is very interesting, and this is the crux of you understanding the world's climate. Please understand this very, very carefully. What is happening at 60-degree north and 60-degree south? Okay, you have wind which is coming from the subtropical high pressure belt, you have wind which is coming from the polar regions, and this wind is forced to uplift along 60 to 65 degrees north and south. So, on 60 to 65 degrees north and south, you are having forced upliftment of air, you are having forced upliftment of wind. So, because of this, at 60 to 65 degrees, you have a low pressure belt that is called as subpolar low pressure belt. Okay, and the wind which will rise up, one arm of that will come towards the subtropical high pressure belt, completing this particular cell. So it will rise up, it will diverge towards the subtropical high pressure belt, and it will complete this particular cell. This is cell number 2. Another wind will move towards the poles and it will sink towards the poles, completing this particular cell. This is cell number 3. So cell number 2 and cell number 3, they are called as Ferrel cell. They are called as Ferrel cell, and cell number 3, it is called as polar cell. It is called as polar cell. Okay, and mind you, both of these cells, Ferrel cell and polar cell, they are all dynamically induced. They are not induced because of the intense vertical convection of the sun, intense vertical insolation of the sun. Okay, the induction of Ferrel cell and polar cell has got to do what? Has got to do two things. Number one, the cells which are being induced, they are dynamically induced. Okay, and these cells induction is dependent on the local factors. Okay, the forced upliftment of the wind at around 60 to 65 degrees north and south. So if I'm showcasing you with regards to my hand movement, so we are, these two winds are coming, these two winds are converging, and these two winds are moving like this. Okay, so these two meetings moving. So imagine this as the surface of earth and you as the upper reaches of atmosphere. So winds coming, winds diverging. So on the surface over here, as the winds are forced to rise up, you will have what kind of pressure belt? You will have subpolar low pressure belt. And but naturally on the poles, as the air is colder, you will have what? You will have high pressure belt. So this is the main reason for induction of pressure belts on earth. Okay, So if I'm quickly summarizing for you all, okay, the pressure belts of the world and the pressure, atmospheric pressure circulation, the atmospheric air circulation for you all. Okay, so in the world you will have what? You will have number first, you will have equatorial low pressure belt. Okay, this pressure belt is thermally induced. This pressure belt is thermally induced. This pressure belt is thermally induced. Okay, then number two, you will have what? You will have two subtropical high pressure belts. Okay, two means number two, quantity two, because you will have one subtropical high pressure belt per hemisphere. And how are these belts being induced? These belts are being induced dynamically. Okay, they are dynamically induced. They are dynamically induced. Okay, their induction has got nothing to do with the sun's insolation. Their induction has got everything to do with the earth's rotation. Their induction has got everything to do with the earth's rotation. Then number three, you will have what? You will have two subpolar low pressure belts. Okay, again, this subpolar low pressure belts will again be what? They will be again dynamically induced. They will be again dynamically induced. Okay, and again the Earth's rotation factor will come into play with regards to this too. Okay, and lastly, you will have what? You will have number two, quantity two. You will have two polar high pressure belts, and these polar high pressure belts, this can be induced thermally. Why? Because as we move from equator towards the poles, the temperature in general will fall. So please keep this in mind, guys. The Earth's rotation has got everything to play in the induction of these pressure belts. And the atmospheric circulation cells that you have, the cells which I discussed, the Hadley's cell, the Ferrel cell, and the polar cell, out of that, only Hadley's cell is thermally induced. The Ferrel cell and the polar cell are dynamically induced. Okay, so I'm talking about these cells, the Ferrel cell and the polar cell. So if I'm writing the cells for you too, okay. So the Hadley's cell, number one, the Hadley's cell, okay, the Hadley's cell, okay, which is existing between what? Which is existing between 0 degree to 30 to 35 degrees north and south. Okay, this cell is induced thermally. This cell is induced thermally. Okay, this is thermally induced. And the two cells, okay, you have the Ferrel cell, you have the Ferrel cell, and you have the polar cell. Okay, the Ferrel cell and the polar cell. Okay, both of these cells, okay, the Ferrel cell is between 30 to 35 degrees north south to around 60 to 65 degrees north south, whereas the polar cell will be between 60 to 65 degrees to 90 degrees north south. Okay, both of these cells, okay, both of these cells, they will be induced dynamically. They will be induced dynamically. Okay, dynamically induced means what? The earth's rotation will have a major say in this. Okay, the earth's rotation will have a major say in this. Okay, so you must be wondering, guys, what are the consequences of rotation of earth? Okay, so this is one of the major consequences of rotation of earth, that the atmospheric circulation which you have on earth is because of the rotation of earth on its axis from west to east. Okay, the variations in season is primarily because of the earth's orbit around the sun, whereas the circulation of wind on the earth is primarily responsible because of what? Because of earth's rotation. So please keep this in mind, guys. The Hadley cell is thermally induced, whereas the Ferrel cell and the polar cell, both of these cells are induced. How? They are induced dynamically. The Earth's rotation will have a say in this. Okay, so please clear this in mind. And Now let's move ahead to the last parts of today's discussion. We'll discuss the wind movements between these pressure belts, and tomorrow onwards we will try to understand the local topography on the maps with regard to this wind movements. Okay, so if now I'm discussing the wind movements between the 30 to 35 degrees north south and the 90-degree north, so I'm again using the half hemisphere of earth for you all. Okay. Okay, so I'm using the half hemisphere for again the discussion. Okay, so let's assume that this is our 30 to 35 degrees north, this is our 60 to 65 degrees north, and that are our polar locations. Okay, so this is our subtropical high pressure belt. Okay, this is our subpolar low pressure belt, and this is our polar high. Okay, polar high pressure belt. Okay, so ideally, how the wind should come? Ideally, how the wind should come? Ideally, the winds from high pressure to low pressure should move like this. Okay, this should be the ideal direction. Okay, this should be the ideal direction from high pressure to low pressure. The wind should come like this from high pressure to low pressure, from high pressure to low pressure. But in reality, which force will again come into play? Mind you guys, in reality, which force will again come into play? The Coriolis force. Okay, so just imagine you are moving from the subtropical high pressure belt. I'm coming towards you. So again, you will have Coriolis force. The Coriolis force will start deflecting the wind towards its right in the northern hemisphere and towards its left in the southern hemisphere. Okay, so this is the ideal direction, but now the actual direction will be like this. Okay, so in actuality, the direction of the wind movement, the wind deflecting from subtropical high pressure belt towards subpolar low pressure belt, it will deflect towards its right like this. It will deflect towards its right like this. This will be the actual direction of the wind movements from the subtropical high pressure belt to the subpolar low pressure belt, and from polar high to subpolar low, the wind again will be directing towards its right like this. So this will be the actual wind movement. Okay, and as these winds are seem to they come from west, so these winds they are called as westerlies. They are called as westerlies, and as these winds seem to come from the polar east, these are called as polar easterlies. These are called as polar easterlies. Okay, so the polar easterlies, and you have the westerly winds. Okay, so what are westerlies? What are polar easterlies? So the westerlies are the winds that deflect from the subtropical high pressure belt towards the subpolar low pressure belt. What are the polar easterlies? Polar easterlies are those winds that deflect from the polar high pressure and they move towards the subpolar low pressure. So please keep these winds in the mind per se. Using this wind knowledge, we will try to explain the vegetation that we have on the planet and the vegetation in general with the regards to the taiga and tundra and the climate of the taiga and the tundra and the temperate region. Okay, so if I'm quickly summarizing this lecture for you all, so in the today's lecture, I explained you the primary reason why do we have the tropical hot deserts on the western side. Why? Because you have winds that come from the eastern side and they struck the eastern shores of tropical lands. These winds they are called as the northeast and the southeast trade winds. Okay, because of this, the rainfall is heavy on the east coast, and as we come towards west, the rainfall decreases. Number two, what we discussed today is this pressure belts of the earth, the atmospheric air circulation. So we discussed the subtropical high pressure belt, we discussed the subpolar low pressure belt, we discussed the polar high pressure belt, we discussed the Hadley's pressures, atmospheric air circulation, we discussed the Ferrel cell, and we discussed the polar cell. Hadley's cell is thermally induced. Ferrel cell and polar cell are both dynamically induced, and you have the winds like the northeast trade winds, the westerly winds, and the polar easterly. Okay, so I'm ending my lecture for you all today. Before ending, I'm again like to quickly point you all my name and the link through which you can join my foray on Telegram. Okay, so my name is Pritesh Maturkar. Okay, my name is Pritesh Maturkar. Okay, you can just search me on Telegram by Geography by Pritesh Maturkar, and the joining link is Geography by Pritesh. Just a global search will do the same thing for you at the rate Geography by Pritesh. You can join the Telegram channel where I keep on posting the relevant tidbits with regards to current affairs discussion. Okay, and I hope that these lectures are having great utilitarian value for each and every one of you. And in due course of time, we will include even advanced level concepts. So tomorrow's lecture will discuss the consequences of these wind movements on the local climate, on the local vegetation, and the local topography too. Okay, so tomorrow we'll move our discussion towards grasslands, towards the taiga forest, towards the permafrost region of the world, and I will introduce to a very good concept called as the polar vortex. Okay, which is very much in news as of previous year. Okay, so thank you all on the behalf of Study IQ IS English, and I hope that we will meet tomorrow and you are utilizing this content properly in your preparation. Okay, I sign off. Take care, everyone. Good night.